Welcome back. We are now going to be going over the remainder of this worksheet, and we're going to be applying it to the same situation, an angry bird getting launched through the air, but it'll be a different angry bird flight path. And if you see, we don't have the equation this time. We just have to interpret things from the graph. Okay, so it says estimate the height of the angry bird when he is 9 feet away from the catapult. So again, we're still in feet, so that's good to know. Okay, so when basically we want to know the height of the angry bird. So is the height an X or a Y value? What do you guys think? Holy hot dog, that would be a Y value. So pretty much what this is asking, okay, that's referring to a Y value. Basically what it's asking is what is the Y value when the X value is 9 feet away? And the reason why I know this is an X value, 9 feet away from the catapult, well, that is going to be a horizontal distance. So this is an X value right here. So I want to know what is the Y value when X is 9. So let's see. Okay, so it starts here. Now, I know you guys, this problem's a little weird. Just to make things a little bit more simple, okay, we're going to assume that the catapult is on the Y-axis and the bird will get launched from the Y-axis. I know that the catapult is technically sitting like here, okay, but the problem just wasn't drawn very well. So technically the catapult should be on the Y-axis. So just assume that it's on the Y-axis and that's where the bird is going to get launched. Because if you remember, the Y-intercept is our start point, which the start point is our catapult. So I know the picture looks different, so we're just going to assume, just to make things a little bit more simpler, that the catapult is sitting on the Y-axis. Okay, so again, just try to keep things up to interpretation in terms of the Y-intercept. But anyway, so I want to know when the bird's 9 feet away, what's the Y value? So basically, what is Y when X is 9? Okay, so I'm going to count over 9. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then I'm going to go up. Let's see where we land. Right here. Okay, so we're at the point 9, and then we're at the point 13. Okay, so the Y value at that point is 13. So we are 13 feet high when we are 9 feet away from the catapult. All right, our next question. The axis of symmetry is provided. What part of the parabola does this pass through? So if you guys remember, when we have an axis of symmetry, what point must always fall on the axis of symmetry when we have a quadratic graph? What is this point right here? Well, that is the vertex. So the vertex always should be on your axis of symmetry. So what part of the parabola does this pass through? The vertex point, which in this case, the vertex is that point. We might as well find it. It's at the point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 and a half. And then we're up to 14. So this is at the point 12.5, 14. Okay, so our vertex point is 12 and a half, 14. Okay, next it says to reflect the points over the axis of symmetry to complete the parabola, and we want to know if we hit any of the pigs on the way. So I'm going to do my best. Again, it's not going to be a perfect sketch, so it might be a little tricky to see if we hit any of the birds, but I'm going to do my best. Okay, so when I do this, you guys, what I'm going to do, okay, I'm going to go to this half of the parabola, and anywhere that I see that the graph lands on like an even mark, I'll reflect it over to get some points. Okay, like for example, this is definitely a point that I can look at. Okay, so the y-intercept is a total of 12 and a half. I know it's 12 and a half feet to the vertex point. So that means I need to go 12 and a half over. So that'd be half, then 1, 2, 3, 4, 5, 6, 7, 8. Let's see here, 9, 10, 11, 12. Here we go. So right here. Okay, then let's see, I'm going to go until I see another good point, which this looks like a pretty solid point landing on an even mark, a whole number. Okay, so I'm trying to look for whole number points because it's going to be kind of hard to approximate. Like this one is like, 0.1 over or something. It'd be kind of hard to approximate that. Okay, so this point is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and a half. So I'm going to go half. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It looks like we're going to hit some Angry Birds. Or the Angry Birds is going to hit some pigs. Let's hear it. The next whole point I see, this one looks pretty solid. Okay, so let's see how far over we are to our axis symmetry. So we're 1, 2, 3, 4, 5, 6, 7, 8, 9.5. Okay, so let's go half. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the next whole number point I see on a nice solid number. This one looks good. Okay, so this is 1, 2, 3.5 away, so half. 1, 2, 3. All right, and I think that's the best I can do. All right, so I'm going to trace over now, and we can see if we hit any pigs. So let's see. But you guys know I'm already bad at doing this, so let's see. So there we go. We have this half of the graph, and it is obvious that we are going to hit at least one pig. We're going to hit this pig. Okay, now another way you could have figured out if you're going to hit any of the pigs, you could have counted like this pig is 1, 2, 3, 4, 5, 6, 7, 8, 9.5 feet away from the axis of symmetry. So if you count 9.5 feet this way, if you land on your parabola, then you know you hit the pig. So like if I counted over, let's see here, half, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you see, I don't quite land on the parabola, so I definitely don't hit that pig. Okay, so you could have like started from the pigs and counted over to your axis of symmetry and then count the same distance over and see if you actually land on your parabola. So that could have been another way. Okay, but we're definitely going to hit this pig. So we do hit a pig. So do we hit any pigs? Yes, unfortunately, we hit a pig, which is sad because we don't want to hit pigs. The pigs are cute. I mean, look at these pigs. They're cute. Don't hit the pig, Angry Bird. Jeez Louise. Okay, but anyways, I know that's the whole point of the game, but it kind of makes me sad when I play the game and I hit the pigs, because then the pigs are all sad. But anyways, our final question of this section. Let's get going. Okay, so it says, what is the C in standard form, or what is the value of C in standard form? Sorry, I cannot read today. Good golly, Miss Long, get together. All right, what is the value of C in the standard form equation that would represent this parabola? Okay, so if you guys remember in standard form, what does the C value represent on your graph? It does represent the y-intercept. So I know this is going to represent the y-intercept, which in this case, the y-intercept is at the point 0, 2. Okay, so what is the value of C in the standard form equation that would represent this parabola? Well, C is your y-intercept value, which is 2. So C would be 2. Okay, and then it says, well, what does it mean in terms of the problem? Okay, again, I know the picture is drawn in a strange way, but like the last time, the y-intercept typically means, well, that is the starting height of the bird, or your start point. Okay, so what does it mean in terms of the problem? Well, what it means, I'm going to separate it. What it means, this is the start height of the bird before it is launched. Okay, so the bird starts at 2 feet before it's launched. So in this case, the bird starts at 2 feet before it's launched. So there you go, you guys. We have learned how to interpret the different parts of the graph that we've been talking about to a more real-world scenario, which I know that Angry Birds are actually not in the real world, but in the Angry Bird world, they are real. So you could apply this to anything getting launched into the air in the real world. So there you go. Wasn't that fun, you guys? I know, I agree. Nice work, you guys. Toodaloo.